explain the passage of the nerve impulse in terms of transmission of an action potential. And we also need to be able to talk about the passage of a nerve impulse at a synaptic transmission, referring to these structures as well. So the next section is talking about how electrical signals are sent along the nerve cell or the neuron through a process called nerve conduction. And so the actual nerve conduction is called an action potential. It's a rapid temporary change in the electrical charge in the neuron. You can see how it's represented here. We're going from the soma to the axon terminals, and you can see normally it's negative on the inside and positive on the outside of the neuron. So the action potential is actually a rapid switch, so it's positive on the inside and negative on the outside, and that is what moves down the neuron. So what do we mean by potential? In electricity, potential is stored energy. It's the potential to do work. And so in physics, we talk about potential difference. And potential difference is where we've got a difference in the charge. In this case, we've got a difference in the charge on the inside and the outside of the axon membrane. So nerve conduction is an electrical impulse along the neuron due to a rapid change in the charge by movement of ions. And we're going to talk about how these ions move. The take-home message is the resting potential is negative on the inside and positive on the outside of the axon membrane. Now, this looks a lot, so I'm going to try and talk you through it quite, systematically. This is what the action potential looks like. We start negative, so this is the difference between the inside and the outside of the neuron. It's negative on the inside and compared with the outside. So the actual action potential, you can see that it becomes positive, and then it rapidly becomes negative again, and then it returns to normal. Okay, so the action potential, positive and then negative. So we need to talk about how we can set this up in the neuron to be able to rapidly become positive and then negative. It does this through sodium-potassium pumps in the membrane, the cell membrane of the axon. To set up this resting potential, which is negative, it does that by creating two concentration gradients that are going to be used later. So using ATP, so this is an active process, the potassium molecules are pumped inside the axon, and sodium is pumped out. Now, whilst this is ridiculous, the way I remember it is I think of pin, sout. P for potassium in, S for sodium out. Pin, sout. Okay, so the resting potential is pin, sout. So potassium in, we're pumping potassium in, so there's a high concentration of potassium in, and pumping sodium out. So there's a high concentration of sodium out. This is negative, and it's staying in this position until the action potential comes along. Then, to make the membrane become positive on the inside, or the neurons become positive on the inside and negative out, we need to rush something positive in very, very quickly. Okay, remember how we set it up. So we put the potassium in and the sodium out. Well, to make it really positive really quickly, the sodium comes in. Okay, so the channel opens up and the sodium rushes in very quickly, passively along its concentration gradient. So all these sodium ions rushing in makes it positive. Now, we need to really rapidly restore the negative charge. So we need to put something positive out, and of course we've set up a concentration gradient such that all of the potassium was in. So now, passively, we allow that potassium to go out, and that makes it negative again. And finally, actively, we're going to pump the potassium in and the sodium out again, pins out, ready to start again. So what I remember is that it's the action potential is all about the movement of ions. we start negative, the action potential is positive, and then we need to rapidly change that again. The way we do it is by using energy to create concentration gradients of the ions. Okay, and I remember pin SOUT. So the resting potential is potassium in, sodium out. Now, depolarization, becoming positive inside, happens by allowing that sodium to go in really quickly. So that sodium is going to come in and join the potassium, makes it positive. Then we're going to allow the potassium to go out, and that's going to make it negative on the inside again. And finally, we return to that resting potential again. And that's it. So just a summary, the resting potential is minus 70. It's created by the sodium-potassium pump, which actively pumps potassium in and sodium out. Sets up those concentration gradients. And the depolarization is when we have the sodium coming in, makes it positive. Repolarization is when the potassium goes out, making it negative again. And then we return to our resting potential again.